Today we are covering our second day of 7-4, and we're going to look more at the graph today. So we want to start by graphing the function and its inverse function. So our first equation, we've got f of x is equal to 1/2 x minus 2. Let's go ahead and start with graphing that. We know we have a linear equation. The y-intercept is at a -2 with a slope of 1/2. So we start with our y-intercept, -2, slope of 1/2 means we are going up 1, right 2. Up 1, right 2, up 1, right 2. And then we can also go down 1, left 2. Now remember, even though my graph is not going to look the greatest, you want to use your ID or a ruler so that you have a straight edge. We want to have good lines on our graphs. And that is representing our f of x equation. Now we want to find the inverse, which we talked about yesterday. To find the inverse, we switch the x and the y. So this becomes x equals 1/2 y minus 2. Now we want to solve for y. So we add the 2 over. X plus 2 is equal to 1/2 y. If we want to get the y by itself, we have a fraction. We have to multiply by the reciprocal. So we multiply by 2. And we've got to make sure that we distribute that 2 to both pieces on the left-hand side. So that becomes y equals 2x plus 2. Oops, I didn't distribute. 2 times 2 gives us 4. So our inverse function is 2x plus 4. Go ahead and graph that. So we start up at our y-intercept of 4, slope of 2, up 2, right 1, or we can go down to left 1. Don't forget, I want straight edges. I don't want to have messy lines. We connect our points. We label this as our inverse function. We do want to label which one is our function and which one is our inverse function. And we know that that is the reflection of the line y equals x. And you know that our line y equals x starts at 0 and has a slope of 1. So this is our line of reflection. And again, we can see that if I were to fold this line over, the blue and the red would fold on top of each other. That is what our reflection means. And now the last part, the new part is f, our inverse function, an actual function? How do we determine if something is a function or not? Well, there is the horizontal line test, which is very similar. It's actually the inverse of the vertical line test. So if no horizontal line intersects the graph of a function f, or f of x, or whatever your function name is, more than once, then the inverse of that function f, or whatever you had chosen, is itself a function. So that may sound a little confusing. Let's go back to our graph. Our original function is f of x. If we're using the vertical line test to determine f of x is a function or not, you draw your vertical line. If it hits no more than one spot at any place, then yes, it's a function. If we want to determine the inverse, we've got to do the inverse of the vertical, which would be the horizontal line test. So if I can draw a horizontal line anywhere on my graph so that it crosses my function no more than one time, then I know that my inverse function is also a function. Personally, I think that might be a little too confusing or more difficult than what it needs to be. In this case, we actually drew the inverse function. So if I want to determine if the inverse is a function or not, I'm going to use the vertical line test on the inverse function. So if I want to determine if the inverse is a function or not, I'm going to use the vertical line test, and I'm going to test it on that inverse function. So in this case, yes, our inverse is a function. So there's just two ways you can look at it. If you only have the original function f of x, then you can use the horizontal line on the original f of x. If it passes the horizontal line test, then the inverse is a function. But if you have the inverse right in front of you, you may as well just use that and use the vertical line test on the inverse function. Okay, hopefully that wasn't too confusing for you. Let's do another one. So let's start with our original function, x squared plus 2. We have an x squared, so we know that it has to be a parabola, which we have done, which we have talked about, so that should be familiar to you. And our parabola has moved up 2 units. So instead of our vertex being at 0, 0, it's at 0, 2. And if you don't remember the shape, that's fine. Plug in points. If I plug in 1, 1 squared is 1 plus 2 is 3. So this is at 1, 3. We plug in 2. 2 squared is 4. 4 plus 2 is 6. And then we know that a parabola is a symmetrical unit, so we can just go ahead and fill the other sides in. And this is representing our f of x. Now we want to find our inverse. So we switch out the x and y, so x is equal to y squared plus 2. We move the 2 over, and then we square root. Because we are solving for something that was originally squared, we now have y equals plus or minus the square root of x minus 2. This is a place where maybe you don't know exactly what that graph looks like, and we don't know yet. We haven't learned about that yet. So this is a place where maybe we want to use either the fact that it's a reflection over our line. So we know that we have our line of reflection starts at 0, 0, has a slope of 1. Again, this is messy. I want to see straight edges on your graphs. Ruler doesn't really work very well on the tablet. So we've got y equals x. We are going to reflect it over that. If you don't like that method, then let's go back to yesterday's video and think about the inverse relation. If this point right here is at 0, 2, the inverse relation is found by just switching the x and the y. So this would be at 2, 0. This one is at 1, 3. If this is at 1, 3, then we would have a point at 3, 1. 2, 6, that would be 6, 2. Negative 1, 3 would be 3, negative 1. And 6, negative 2. So there's a couple different ways you could have gone about finding that inverse relationship, especially since we are not as familiar with that equation, the square root of x minus 2, which we will be in a couple days. Don't worry about that. Alright, so we see our inverse relationship, and we do see that it is that reflection over the line y equals x, and we want to determine, is the inverse a function or not? Again, I told you I preferred, if I have the inverse function, which I did not label, I'm going to go ahead and just use the vertical line test on that inverse function. If I draw my vertical line, I see right away that it's going to hit in more than one spot. So no, the inverse is not a function. We see that our f of x, our original function, is, but the inverse is not. When I flip that parabola over, it's hitting in more than one spot. Okay. We only have one more to go, and we are done. And we're still doing the same thing. Graph the function and the inverse, and then determine if the inverse is a function or not. So we have 1/2 x cubed minus 2, which again, we have looked at these graphs before. If you don't remember, that's totally fine. Plug in values. So we plug in 0. 0 cubed is 0. 0 times 1/2 is 0. So our starting point there is down at negative 2. We plug in a 1. 1 cubed is 1. 1/2. 1/2 minus 2 is a negative 1/2. negative 1 and 1/2. We plug in 2. 2 cubed is 8. Half of 8 is 4. 4 minus 2 is 2. Let's go in the other direction. We've got our negative 1. Negative 1 cubed is a negative 1 times 1/2 is a negative 1/2. So we are at negative 2.5. Negative 2 would be a negative 8. Half of negative 8 is negative 4 minus 2, and that's a negative 6. Again, I just plugged in those x values, and we know this is a cubed function, so we should expect to see that little turn of a graph. We label that as our f of x. We know that we still have that line of reflection for our inverse. It's still going to be reflected along that line, y equals x. Now what I want you to do is I want you to come up with the inverse equation on your own. So switch your x and y and solve for y. Once you're done with that, check your equation before we go on to graphing. So go ahead and press pause. Alright, hopefully you got our inverse function as the cube root of 2x plus 4. If you didn't, go back, compare your work to my work, and see where you made your mistake. This, again, is a graph that, we may not be very familiar with, and we haven't learned about this yet, but you do know that there's a couple different ways that you could graph your inverse function. One, plug points in the way we did in the original function, or the inverse function is always the switching of the x and the y coordinates. So we started with 0, negative 2. If I switch those two coordinates, that is negative 2, 0. 1, negative 1.5 becomes a negative 1.5, 1. 2, 2, that's still 2, 2. We go in the other direction, a negative 1 and a negative 2.5, so that's negative 2.5, negative 1. Negative 2, negative 6 becomes negative 6, negative 2. And we can see that that relationship has been reflected over our line y equals x, and our snake graph that was going up and down is now going sideways. And now we have to determine if it is or if it is not a function. Again, I'm going to use the vertical line test on our green, our inverse. If I do my vertical line everywhere along this line, it's not going to hit more than once in any spot. Therefore, yes, it's a function. And I guess I should say our inverse is a function. Alright, so just remember from today's video, when you are graphing, you have your original function. If you don't know what it's going to look like right away, plug in points to find it. Find the inverse equation by switching your x and y and solving for y. And then either reflect it over the line y equals x, or switch your x and y coordinates to find the graph of your inverse function. Alright, we're all done for today.